So in this class we will discuss some problems on coplanar non-concurrent force systems, finding the resultant force. So let me discuss the model question paper problem of VTU. Model question paper VTU. So the problem is like this: determine the magnitude, direction, and position of resultant. So we have to find this. See, figure is given like this. This is a rectangular lamina. On this rectangular lamina of dimensions, this is 2 meters. This is 1.2 meter width. So he has given, so A, B, C, D is the rectangular lamina. On this lamina, he has given forces like this. There is a 4 kN force towards right, joint at joint B. There is a 6 kN force, vertical force acting downwards at a distance of 1 meter from B, like this. That is midpoint of BC. Then you have an anti-clockwise couple or moment of 8 kN acting at the point D here. Then you have a 5 kN force acting like this with an inclination of 1 vertical to 2 horizontal. We have not given the angle. So this is the diagram given. So we have to find the resultant of this force system. You can see that since the lines of action of the forces, they are not meeting with a common point. It is a coplanar non-concurrent force system. So we have to find the magnitude, direction, position of the resultant force. It is nothing but a single force which has the same effect as the combined effect, of all the given forces. Now the procedure is like this. First we have to resolve the forces, and we have to find out the algebraic sum of the forces acting in global x direction and global y direction by treating forces acting towards right positive and upward positive. So we have resolved the forces here. For that I have to resolve this 5 kN force. If I thought I want to resolve the 5 kN force, I need to find the angle. So this angle I need to find. So this angle will be, so tan inverse of 1 by 2, which is nothing but 26.56 degrees. So opposite side by adjacent side. So this angle becomes 26.56 degrees. If we resolve this, this becomes 5 cos 26.56 degrees. This becomes 5 sin 26.56. So only this is the inclined force. The other two forces are not inclined. Therefore, you need not resolve that. Now, if I want to write sigma fx, treating forces acting towards right positive, this 4 kN is positive. This doesn't have any horizontal component, and here this horizontal component is negative, minus 5 cos 26.56 because it is acting towards left. So sigma fx will be now 4 minus 5 cos 26.56 degrees, so which comes out to be minus 0.472. Please check this kilonewton. So minus times that it is acting towards left. Next, sigma fy, this doesn't have any vertical component. This is negative because it is acting downwards. So minus 6, and component of this also is negative, minus 5 sine. Minus 5 sine 26.56 degrees, which comes out to be minus 8.236. Please check the values using your calculator. Downward, negative downward. So therefore, magnitude of R, resultant force is equal to R, which is square root of sigma fx square plus sigma fy square. So if you simplify that, you will get so minus 0.472 square plus minus 8.236 square under root. If you simplify that, you will get 8.25 kilonewton. So this is the magnitude. So please note that when you are finding sigma fs and sigma fy, we are not considering this external moment given in the problem or couple given in the problem, because this is algebraic sum of forces. That's why this is not considered. This we are going to consider when you are finding the moments, algebraic sum of moments. Now this is magnitude of r, then direction of r, which is given by alpha. Alpha is equal to tan inverse of modulus sigma fy by sigma fx, which is tan inverse of minus 8.236 divided by minus 0.472. So this becomes positive, and if you find the tan inverse of that, you are going to get alpha as 86.7 degrees. 86.7 degrees is the value of alpha. So now we can get the unit coordinate that r lies by knowing the values of sigma x, the directions of sigma fx and sigma fy. So sigma fx is acting towards left, sigma fy is acting downwards. Therefore, your r should come like this, and this is alpha. Alpha is the angle made by the resultant with x-axis or with the horizontal. Now this is the direction of r. That means r lies in the third quadrant. So by knowing the directions of sigma fx and sigma fy, you can decide in which quadrant that r lies. Now after finding magnitude direction, now the third point is finding the position. So here we are not given with respect to what point you have to find the position or locate. You have to locate the resultant. So I will take this point A. So position of r with respect to point A. Position of resultant force. If I write arrow here, it is force with respect to point A. So to find the position, I need the algebraic sum of all the forces about the point under which about which we need the position. So now I have to find the distance of this r from the point A. So the distance, perpendicular distance of resultant force r from the point A is nothing but d here. So d we are going to find out. For that we have to calculate the algebraic sum of the moments of all the forces about the point A now. Now if you take one by one, this force, 5 kN force is passing through A, therefore this doesn't have any moment. This 4 kN force is producing a clockwise moment about the point A. So clockwise I am taking positive. So 4 into distance is 1.2 meter. So 4 into 1.2, this is the clockwise moment about the point A for this force 4 kN. Then the 6 kN is also giving a clockwise moment about the point A. Distance is 1 meter. Please note that for horizontal forces distance is vertical, for vertical forces distance is horizontal. So plus 6 into 1 meter. So plus 6 into 1. Then this moment we have to consider now. Please note that this moment we are not taking when you are writing sigma f sigma fy, but when you are finding the moment about any point, we have to consider that moment. So one property of this couple is that wherever it acts, its effect remains the same. That is what the characteristic of the external moment or couple. So the rotation effect of this moment is same wherever it acts. So therefore, we are not multiplying this gate by the distance. So it remains same, effect remains same. That means just we have to take the magnitude of this couple or moment, whatever is given. Since it is anti-clockwise, I will just write it as minus 8. That's all. Suppose if it is clockwise, you have to take this as plus 8. So whether 8 kN acts here or here or here or here, wherever it acts, even if it acts at A, you have to take that because it is a moment. So the effect of this whatever external couple or moment is given, that remains same wherever it acts in the plane of the forces. So this is minus 8 because it is anti-clockwise. Now if you simplify this, you are going to get 2.8. So 2.8 is the kilonewton meter. Please note, unit is kilonewton meter. It's positive. Positive means it is clockwise. So the moment of the forces as well as the external moment given about the point A is 2.8 kilonewton meter. Now the distance, perpendicular distance, that is from perpendicular distance of the resultant R from point A, that is nothing but D. D is given by, as we know, modulus sigma MA by R. Because we are taking the distance from the point A, we are calculating sigma MA. So it is nothing but now modulus 2.8 divided by R is magnitude of the resultant, which is 8.25. So if you simplify that, you will get 0.34. 0.34 meters is the distance, perpendicular distance of the resultant from the point A. Now we have to check at what position that R lies with respect to point A. This distance is very important because now you know the distance from the point A, perpendicular distance from the point A to the resultant. Now the question is whether that R acts above this point A or below this point A. Now you know the direction also. So direction is like this. Direction is like this. Now the question is, this is fixed now. Third quadrant. See here, I have shown here. But the thing is, with respect to position, whether from the point A it lies above the point A or below the point A. For that, what you have to do is, you please check the nature of the moment MA. Nature of the moment MA due to that R. It is clockwise here. You can say 2.8 km clockwise. Clockwise means you just check up among these two which gives the clockwise moment about A. So if you observe this R gives a clockwise moment about A. Therefore, this is the position. So this is not the position. So the distance from this point A to the line of action of R, this is D. So it is 0.34 meter. So to decide on which side of that point A the resultant acts, we have to draw the directions of the resultant, and then we have to decide among those two. There will be two possibilities. Then among those two, whichever gives the nature of the moment we have got. Here we have got clockwise. So therefore, among these two, whichever gives clockwise moment about the point A, that is the correct direction of R. Now the direction of R here is this, and here this angle is your alpha, or this angle is your alpha direction. See, with respect to horizontal. So this itself is taken as the x-axis. This itself is taken as the y-axis. So that is how we have to locate the resultant. Now one more thing which I may ask. What about the x-intercept and y-intercept of the resultant? Sometimes they will ask you to find the x-intercept and y-intercept of the resultant force with respect to the point A. So now I will tell you how to find that. Now once you judge it, once you decide in which direction and in which position. So here this is B, A, this is B. So I am going to make this as y-axis, this as x-axis. See, the point about which we are finding the intercepts, that point is A here. You draw x-axis and y-axis passing through that point. Now we have the resultant acting like this. This is the resultant force, and the angle made by the resultant is this alpha. So this is how we got. Now this is B. This is B. Perpendicular distance from point A to that line of action of R. Now x resultant is, this one is x resultant. So this is nothing but x result, x intercept, x intercept. And y intercept is, you just extend this. Wherever it cuts this R, this is y intercept. So these distances are called as x intercept and y-intercept. The line of action, wherever it cuts the x-axis. So from the point at important consideration to that point. Suppose if I take this point as M, this as N. So this AM is called as the x-intercept of the resultant, x-intercept, and AN is called as the y-intercept. Y-intercept. So x-intercept I will take it as small x, y-intercept I will take it as small y. Now D, as you know, it is the particular distance of the resultant from the point A. Now you have to consider these two triangles. Let me take this as P. In triangle APM, you just take, I want this distance, so this becomes the hypotenuse now, this becomes the hypotenuse. So if I take cos alpha, or if I take sin alpha, in this triangle if I take sin alpha is equal to AP divided by AM, opposite side by hypotenuse. So you know that AP is D, AM is x. So therefore sin alpha is equal to D by x, or x is equal to D by sin alpha. So this is the equation, which the expression which gives the x-intercept. Similarly in this triangle APN, that is also a right angle triangle. In triangle APN, you take cos alpha. So what is cos alpha? You see, when this is alpha, when this is 90, so actually what happens here, this becomes alpha. From the geometry this becomes alpha. So this is 90, so this is alpha, this is also alpha. When this is alpha, this is 90 minus alpha, this is alpha. So cos alpha will be on similar lines AP divided by AM, adjacent side by hypotenuse. So here also it is D by Y. So therefore cos alpha is D by Y is equal to D divided by cos alpha. So using these two expressions, x and y expressions, we can find out the x-intercept and y-intercept. So we will be knowing D, and you know the value of alpha also. So in the present problem, so D value is 0.34 meter, alpha value we got 86.7 degree. Just to substitute those values, and if you simplify, you will get the x-intercept and y-intercept of the resultant with respect to point A. So what we have done here is, at the point, from the point A we have our x-axis and y-axis, and wherever the resultant cuts the x-axis, that point is M here. Wherever it cuts the y-axis extended, that is point N. So then AM is x and AN is y. D value will be knowing, alpha value will be knowing. So from this we have got the relationship. Now in this problem, x is equal to D by sin alpha. D by sin alpha, D is 0.34 divided by sin alpha is sin of 86.7 degrees, 86.7 degrees, which comes out to be x value 0.341 meter, that is the x-intercept, which is AM here, and y is D by cos alpha, which is 0.34 divided by cos of 86.7 degree, which comes out to be 5.91 meters. So 5.91 meters. Anyway, the sketch is not to scale. So this distance is y, this distance is x. These two are called as the x-intercept and y-intercept. So if they ask you to find x-intercept and y-intercept, this is additional step we have to do. So after locating the resultant, so we can directly use the formula x is equal to D by sin alpha, y is equal to D by cos alpha to get the x-intercept and y-intercept. Of course, these things I have explained just to arrive at the expressions. You need not do this in a problem. If they ask you to do the derivation, you have to show. Otherwise, in a numerical example, you can just write this formula and substitute. You will get the values of x and y. Of course, they are the positive values. Here you may see that this is downwards, but distance only is important. Distance I am considering, magnitude only I am writing. So y magnitude is 5.91 meter, x magnitude is 0.341 meter. So in whatever quadrant it lies, so we are not bothered about the sign. So because distances are always measured as positive values. So this is one problem. The next problem, So is a problem on an equilateral triangle. So you can just see this is also a model question paper problem. It's an interesting problem. You can see here. So case of coplanar non-concurrent force system only. Only thing is here the forces are given. They are acting along the sides of an equilateral triangle. So the problem runs like this. Determine the resultant with respect to point B. Figure is given. So determine the resultant with respect to or with reference to point B. So of course here also it is understood that if they give like this, determine the resultant. If they give, if it is non-concurrent force system, we need to find all the three: magnitude, direction and position. So here ABC is an equilateral triangle. That's what he has given. Equilateral triangle. So it is like this. So the equilateral triangle means all the three sides are equal, angles are equal. 4 meters he has given as the length of each side. He has given the forces like this. ABC is the equilateral triangle. A, B, C. So all the three sides are equal, 4 meters length. So angles will be 60 degrees, as you know. Now the thing is here, one force he has given along this gate, 200 Newton, acting like this. Another force he has given here, 200 Newton. Another force he has given along the edge BC, that is also 200 Newton. So these are, this is 60 degrees. Okay. Now, so if you extend this becomes 60. So all the angles are 60 degrees now. Only three forces are given. He has asked the resultant with respect to point B. He has asked. This is an interesting problem. So in this problem, you can see here that procedure is remains same. So we have to find magnitude, direction, position of resultant. So let me write sigma fx and sigma fy as usual. Forces acting towards right positive, sigma fy upward forces positive, downward negative. So if you resolve this, naturally the resolution will be like this. So you have the horizontal component towards left, vertical component upwards, 200 cos 60 and this is 200 sin 60. Coming to this, so this is the horizontal component, this is the vertical component, 200 cos 60, 200 sin 60. Now if I take sigma fx, this is negative because it is acting towards that, minus 200 cos 60. This is plus 200, no resolution for that, minus 200 cos 60. That one is. So if you simplify this, cos 60 is half. So if you simplify this, you will get 0. This becomes 100, this becomes 100. Minus 200 plus 200 is 100. That is 0. So sigma fx is 0. Next sigma fy. This 200 sin 60 is positive. 200 sin 60 is positive because upwards. This doesn't have any vertical component. This is negative. Minus 200 sin 60. So you can see that this is also 0. So this is also 0. So both sigma fx, sigma fy are 0. So magnitude of R, you know that sigma fx whole square plus sigma fy whole square. This also becomes 0. This doesn't mean that the resultant force is 0, but there can be a moment. Resultant can be a moment. So I will write here the meaning of this is resultant force is 0. Okay, there is no resultant force. But in such a case, it may be subjected to a resultant moment. So please note that there may be a resultant moment possible. They make resultant moment. How to calculate that? So for that, what I have to do is say, anyway is asked resultant with respect to point B, I will take sigma MB. By considering forces acting, clockwise positive, anti-clockwise negative. Now I will take this point B. This point B will not have any moment due to this 200 Newton force because it is passing through this B. Now coming to this, what happens? There are two forces here, horizontal and vertical. These two will give moment about the point B. Now let us calculate what is the moment. For that, I need this distance. Since it is an equilateral triangle, this is 4 meters, this also will be 4 meters, and this also will be 4 meters. This becomes the midpoint. So this D becomes the midpoint. So now I want this distance, vertical distance I need. This will be anyway 2 meters because it is midpoint. This is 2 and 2. AD will be 2 meters, DC also will be 2 meters. But I need this vertical. If you want the vertical, you take sin 60. Sin 60 is equal to, if I take this as h, so sin 60 is equal to h divided by 4. Please note that. It's right angle triangle. Sin 60 is equal to h divided by 4, or h is equal to 4 into sin 60. 4 into sin 60 is, I think, 3. Just calculate that, 464. 3.464 meters. So why I need this h value is this force 200 cos 60 force, it is giving a clockwise moment about B and the distance is this h. Now I will write the moments now. So this force 200 cos 60 is giving a clockwise moment about B, so it is positive, clockwise is positive. 200 cos 60 into h is 3.464. Then this moment, this force will give an anti-clockwise moment about B. See the arrow, you have to come like this. So minus 200 sin 60 because anti-clockwise, minus 200 sin 60 into distance is 2 meters. See, from the point B, distance to this force is 2 meters. So minus 200 sin 60, minus 200 sin 60 into 2 meters. Okay. Next, coming to this 200 Newton force, it is giving an anti-clockwise moment about B. See the arrow move towards B. Minus 200 into this distance I have taken once again h. So minus 200 into h, that is 3.464. And of course this force will not give any moment, this or this. So these two forces, they won't give any moment about B because they are passing through B. So distance is 0. Now if I simplify this, let us see what is the moment you are going to get. So 200 cos 60 is nothing but 100 because cos 60 is half. So 100 into 3.464 is 346.4. 346.4 minus 200 into 3 is 400 into sin 60 is equal to, then minus 200 into 3.464. So this is the value of that moment. You are getting minus 692.8. Minus 692.8. Minus 692.8. Unit is Newton meter. This moment. So minus stands that it is anti-clockwise. That means this moment is same wherever it acts in the plane of the force. So since he has asked the resultant with respect to point B, I have considered sigma MB, and the sigma MB itself is the resultant moment. So please note that here the resultant moment are a couple. So it leads to a couple. So that means 692.8 Newton meter anti-clockwise. The meaning of this is due to the application of these three forces, the total effect of this force, and this force is that it rotates the object, that is, it rotates this equilateral triangle object in the anti-clockwise direction with this moment. That is the answer. So whenever in some problems you may get sigma fx 0, sigma fy 0, the meaning of that is the resultant force is 0. But the resultant may be a rotational effect also, because resultant may give translating effect as well as rotational effect. In this case, you have only rotational effect, there is no translating effect. So please note that that's why I have taken this problem. So the note we have to take here is resultant R gives both translatory effect as well as rotational effect on a body. Rotational effect. So in the above problem, since sigma fx is equal to 0 and sigma fy is equal to 0, there is no translatory effect. That is, the body, that triangle, whatever is there, that lamina won't move. It won't move. So this is the equilateral triangle. This will not move in this direction, or this will not move in this direction. That is not there. Whereas this can rotate in the anti-clockwise direction. So with that whatever MB or MA, so this value of this MB, it is same. Whether if we calculate the sum of algebraic sum of the moments about the point A, that also we are going to get same value. That is the meaning of that. So if there is a check, so it's a check, because that moment it will get same. Sigma MB is the same as sigma MA is the same as sigma MC. So wherever you calculate the moment due to these three forces, you are going to get the same value of the moment. That is why it is a constant couple. So this resultant couple is a constant value. So that is the resultant. So it's a special case wherein both the sigma fx, sigma fy are zeros. That indicates that there is no translatory effect. But due to the application of those three forces acting at A, B, C, so it can have a rotational effect, which is in the anti-clockwise sense, because we have got negative sign. Suppose if you get positive sign here, this effect is clockwise coupled. So this also is possible.